So I'm Laurence Moroney. I'm from Google. I work on Firebase and I work on Geo. Immediately after this, I'll be doing a talk on Firebase. So if we run over, I don't mind. It's cutting into my own session. So in this talk, I'm going to talk about Geo and the power of geolocation. And one of the passions that I have is really dealing with Google Maps and building apps that use Geo and use Geo smartly. But the one thing that's relatively unknown is that you can actually get pretty accurate geolocation without a GPS circuit. And this is more and more important as we go into the world of the Internet of Things, where small, cheap devices, that don't have GPS, that you don't want to pay, like for example, like a Raspberry Pi Zero, you're not going to have a GPS circuit on that. It's a $5 computer or a $10 computer. And but what it does have is Wi-Fi and has a Wi-Fi circuit. So we have a thing called the Geolocation API, so that if you sniff for Wi-Fi access points around you, or if you sniff for cell access points around you, you make a call up to this thing and it'll give you back an estimate of your current location in the world based on that. So I want to talk a little bit about the technology that underpins that. So for example, if you have something like this, you have Wi-Fi access points near you, you have cell access points near you, you can estimate the distance from them, and then you can trilaterate where you are based on the distance from each of these. And this is done using an algorithm called the free space path length. So the free space path length is the equation that you can see on the board behind me, and it's 20 log d of the distance plus 20 log d of the frequency of what you're scanning, like a 5 gigahertz access point, a 2.4 gigahertz access point, plus k, where k is a constant, will give you the decibel reading. But when you do a scan for, like if you're in Linux and if you do a scan for like Wi-Fi access points around you, you get the decibel reading, you know the frequency, you know k, and from all that you can figure out d. So what it'll give you is something like this. So say you're doing a scan for these access points, and you'll say, I know I'm this distance from this one, and when you know the distance, what you have is a radius of a circle. I'm this distance from this one, I'm this distance from this one, and the overlap of these will give you a rough estimate for where you are in the world at this moment in time. Now, we have an API where we know the location of a number of Wi-Fi access points around the world, and we know the location of many cell towers around the world. So if you use our API, and you, for example, do a scan of like the Wi-Fi access points around you, the cell towers around you, and you get their MAC address, or it's called a BSS ID sometimes. And if you put it in JSON in a blob like this one, where you just say, here's the Wi-Fi access points that I see, here's the signal strength that I've read, here's the signal to noise ratio that I've got, and you pass it up to our API, which is googleapis.com/geolocation, as you can see here. What it will do is it will give you back this, which is location with a latitude and longitude of where it thinks you are right now, by doing that trilateration, and an accuracy reading. So this case, the accuracy reading, when I did this thing, I was within 20 meters of that latitude and longitude. Now, of course, you're not just limited to using our API to do it. You could use the free space path length algorithm. For example, if you're building a system for determining an indoor location and you set up Wi-Fi access points yourself, you know where those Wi-Fi access points are, and then you do a scan to get the signal strength for those, and then you can trilaterate and get like an indoor location yourself. Here's an example of a project that I was working on, that I built a robot, and the one I built is the one on the right, not the one on the left. And this robot had a Raspberry Pi backplane, and Raspberry Pi runs Linux. And in Linux, you've got a command, sorry, it's really hard to see, but sudo iwdev wlan0scan command in Linux will give you a list of all the Wi-Fi access points that you can see along with their signal strength. So from that, achievement unlocked, I'm able to put a regular expression in a talk slide. Using a regular expression, you can pull out the MAC address of all of these, you can pull out the signal strength of all of these, and then you can bundle these into a JSON file, which you then call the Google API's geolocation with. You need a key, you get a free developer key on our developer site, and then that was able to return the actual location of the robot. And I was doing a talk in San Francisco last month that I built this robot for, and here was an example of where I was going from my hotel to where I was doing the talk in a taxi, and I was running, like every 20 seconds, I was running a scan of Wi-Fi access points near the taxi and getting a latitude and a longitude back. And it gave me these latitudes and longitudes, and it was mostly accurate. I was in the hotel at the top of the image there, and I was speaking in the Moscone Center West in the center of the image, and I was able to get these ones back just by running that command and calling the API. And this was, like I said, it was on a Raspberry Pi backplane, no GPS on it, just basically sniffing Wi-Fi signals around me. And with 20 seconds left, I'll say thank you very much.